Here's an integral we can evaluate using partial fractions, even though it doesn't initially appear to be a rational function. We will start by substituting u equals the square root of t plus 3. Then the du is 1 divided by 2 square root t plus 3 dt, or in other words, 2 du is equal to 1 over the square root of t plus 3 dt. We will also need to solve for t. T equals u squared minus 3. Now, performing this substitution on our original integral, on the top of our fraction, we have 4t plus 21, but we are substituting u squared minus 3 for the t. On the bottom of our fraction, we have t plus 7, substituting u squared minus 3 for the t. We have this. And then the square root on the bottom here, together with the dt, turns into 2 du. Now I'm just going to do some algebra to clean up. The 2 can come out front. On the top I can distribute the 4. We have 4u squared plus 9. And on the bottom I can combine those terms to get u squared plus 4 du. Now I notice that the top and the bottom of my fraction have the same degree. Therefore, I need to simplify this fraction before I go any farther. To do this, I can either use polynomial long division, or I can just write the top in a very convenient way. So I'm going to write the top of this fraction as 4 times u squared plus 4. Notice 4 times 4 is 16, but I'm only supposed to have plus 9. So I'm then going to subtract 7. And the bottom is u squared plus 4. Now, the advantage to writing our integrand in this way, I can take each of these two large terms on the top and divide them each by u squared plus 4. When I divide the first term, the u squared plus 4 cancels, so I have 4, and then minus 7 over u squared plus 4. However you get from this step to this step, I don't care. You can rewrite it the way I did, or you can use polynomial long division. At this point, we can just integrate each term. We have a 2 out front. The antiderivative of 4 is 4u. Then we have minus 7 times 1/2 times tangent inverse of u divided by 2. Now cleaning up a little bit, we have 8u minus 7 tangent inverse of u divided by 2 plus c, and substituting the t's back in for u, we have 8 times the square root of t plus 3 minus 7 times tangent inverse of the square root of t plus 3 divided by 2 plus c.